Hello, M3 students. Welcome back. We are going to continue talking about the angle relationships that occur when there are intersecting lines. So we just looked at a bunch of different vocabulary. Now we're going to kind of put it into action and see what's going on. So the first thing, it says measure each angle in the figure above. So I've got my handy dandy protractor here. And for those of you who don't remember how to use a protractor, you've got this little center circle here, and then it's on this line. So we're going to put the circle on the vertex of the angle, and then line up this line on the protractor with one of the rays of your angle. Now, as you can see right here, that's the other ray of my angle. It's kind of short, so I'm going to just extend that. Okay, so now it's all lined up. I'm going to do angle 1 first. So this would be 0. So 0, 10, 20, and so on up to where that ray is. And it looks like it's at right around 50 degrees. So 50 degrees for angle 1. And so then let's put the protractor back on so we can do angle 2. This time, this is where 0 is. That's the ray of the angle. So 0, 10, we're going to use the inside numbers, 0, 10, 20, 30, all the way around. And that's at 130 degrees. Now, realistically, we didn't even have to measure the second angle. This is a straight line, and we know that two angles that make a straight line have a sum of 180 degrees. They're supplementary. So I actually could have done 180 minus 50 to get the 130. And we're going to use that same reasoning to figure out that angle 4 is 50 degrees, and then angle 3 is 130. So now let's go down. I'm going to measure angle 5. There's angle 5, and look at that. That is 50 degrees as well. Some similar numbers here keep popping up. Using the supplementary angles, angle 6 is 130 degrees. Supplementary angles helps us figure out angle 8 is 50 degrees. And finally, angle 7 is 130. So which line appears to be the transversal? That would be line C. It's going through both A and B. So that's C. Don't forget proper notation with that double-ended arrow above the letter C. And what do you notice about lines A and B? Well, here's A and B, and they appear to be parallel. They are parallel. So you're going to want to add that notation on to show that they're parallel. So some people use little arrows, kind of like I just did there. Sometimes you see little triangles on the line, but there is usually notation to know if lines are parallel. Give an example of vertical angles. So this is using that vocabulary from the last lesson. So I'm going to pick angle 1, and the angle that's vertical to angle 1 is angle 4. And you could have used any of the pairs of vertical angles. You didn't have to use 1 and 4. What do you notice about the angle measures? Well, angle 1 and angle 4, they are both 50 degrees. They have the same measure. They have the same measure. Give an example of corresponding angles. So I'm going to pick angle 2. That is to the right of the transversal and above the line cut by the transversal. So corresponding to angle 2 would be angle 6. Again, you could have chosen any of the possible pairs of corresponding. I just happened to choose 2 and 6. What do you notice about the angle measures of the corresponding angles you chose? 2 and 6, they're both 130 degrees, so they have the same measure. Give an example of alternate interior angles. All right, I'm going to pick angle 4. And angle 4 would be alternate exterior with angle 5. Angle 4 and angle 5. What do you notice about the angle measures of those alternate interior? They're both 50. Same answer again. They have, whoops, making mistakes. Nobody gets points for that. They have the same measure. All right, finally, give an example of alternate exterior angles. So let's see, I'm going to pick angle 1. Angle 1 would be with angle 8. And what do you notice about those angle measures? Guess what? They're the same as well. They have the same measure. Okay, well, they have all these different types of angles have the same measures because these two lines were parallel. So when the lines are parallel, vertical angles, corresponding angles, alternate interior angles, and alternate exteriors, each angle in those pair, they have the same measure. What happens when the lines aren't parallel? So take a look at the next figure, and you can see all these different angles. This definitely looks different than the one up above, doesn't it? So we're going to measure again. Let's start with angle 1. Angle 1, let's see. That looks like about 150 degrees, which means angle 2 would be 30 degrees. Using the supplementary angles. Same thing, angle 7 we can figure out as 150 degrees, and then angle 8 would be 30 degrees. Let's come over here. Let's check out angle 3. Let's see, I'm going to extend that. Okay, so angle 3. Oh, I didn't extend it far enough. Okay, so angle 3. 0, so we're going to use the outside lines. It looks right about 85, maybe. Oh yeah, about 85. So 85 degrees for angle 3. Using the supplementary angles, angle 4 would be 95, angle 5 would be 85, and angle 6 would be 95. Which line is the transversal? So line P cuts both of these two lines. So line P. Lines Q and R parallel? No, they are not. Okay, give an example of vertical angle. So I'm going to pick angle 1, and vertical to angle 1 would be angle 7. What do you notice about the angle measures of the vertical angles we chose? They have the same measure. They have the same measure. Okay. All right. Let's see if we can leave that figure here as we move to the other questions. Okay. Give an example. All right, that works pretty good. Give an example of corresponding angles. So angle 1 is above the transversal and to the left. So angle 3 is also above the transversal and to the left. So angle 1 and angle 3. Are the corresponding angles that we chose congruent? Do they have the same measure? 1 and 3? No, they do not. Give an example of alternate interior angles. Angle 2 and angle 6, 30, 95. So angle 2 and angle 6, 30 and 95. No, they are not congruent either. Give an example of alternate exterior angles. All right, let's go 8 and 4. Angle 8 and angle 4. Do they have the same measures? No. Okay, so what did we find out? Vertical angles, does it matter if the lines are parallel? No, vertical angles are always going to be congruent, whether the lines are parallel or not. All of the other types of angles, as you can see here, are only congruent when the lines are parallel. Okay, so this right here, this is all important stuff you want to make sure that you understand. Okay, so last section, just kind of applying the things that we know. It says use the figure below to answer the following questions. And it says, assuming that the measure of angle 1 is 110 degrees. So angle 1 right here, 110 degrees. I can label that. We know that. We do not know anything else. We have not proven any other angle measures, and we need to use the things that we know about the different types of angles in order to do that. So what is the measure of angle 4? Angle 4, well, it's supplementary to angle 1, so that means angle 4 would be 70 degrees. Explain how you know using your new vocabulary. So angle 1 and angle 4 are supplementary angles. Make sure you're specific. Don't just say they are supplementary angles, because we don't know what they is. Be specific and state what two angles you're talking about. What's the measure of angle 7? So we can do one of two things here. We already have established that angle 4 is 70. We've proven it. We've said it right here. So you could work with 4 and 7 and say that they are supplementary to figure it out. Or you could work with angle 1 because 7 and 1 are vertical. And that's actually the route I'm going to go. So what's the measure of angle 7? Well, it would also be 110 degrees. We know this because angle 1 and angle 7 are vertical angles. And we know vertical angles are always going to have the same measure. And then finally, what is the measure of angle 8? So angle 8 is down here. Let's go back. We can label that angle 7. We've proven that one. So you can do a couple of different things. I could say 8 and 7 are corresponding, so they'd have the same measure. I could say 8 and 1 are have the same measure because they are alternate exterior. So there's a couple of ways that we could do it. So what is the measure of angle 8? Let's go, we're going to go the root, angle 1 route. So it's 110 degrees. And how do we know this? Angle 8 and angle 1 are alternate exterior angles. And we know alternate exterior angles are always congruent as long as the lines are parallel. Now, I'm sure at this point, somebody has caught the fact that there is no proof that these two lines are parallel. They are missing the notation. So I'm going to add that in there. It should be there. Yes, that is a mistake. No points for any teams, though. But those lines are parallel. They should have that notation. All right. I hope that you've enjoyed this and it has helped you out. If you've got any questions, please don't hesitate to contact your teacher. I will be ready soon with the next video. Have a good day.